Hello and welcome to the channel. I'm your host E-Day, bringing you some more of my immersive engineering spotlight. And today what we're going to go over is how to use the water wheel in immersive engineering in Minecraft 1.20. So the water wheel is used to make passive power. So I'll be showing you guys how to get power in immersive engineering, specifically in Minecraft 1.20. So last time we went over passive power with the thermoelectric generators, and before that we did passive power with the windmills. Today we're going to be working on this bad boy here, which is the water wheel from immersive engineering. I made one of them because I always get the dimensions a little bit wrong. So I wanted it to be completely streamlined for you guys. So before I remove the current generator with the trash can here for you guys, let's see, it is running at 81 flux per tick. This is not the 100% min-maxed version. I believe you can get it up to 88 RF a tick, but it involves a lot more work, a lot more troubleshooting, and this to me is the easiest way to teach you guys how to set up the water wheel, and you'll only be losing 7 RF a tick, but it is much easier, and as you can see, it looks really nice, minimalist like this. So let's get rid of this here, and we'll get rid of this guy, and I can show you guys how to put together the water wheel for immersive engineering. So before we start putting stuff down, let's go ahead and make the items required, the bare minimum items that are required, which is the kinetic dynamo and of course the water wheel. We're going to use 3 of them. So like we did in the previous episode with windmills, we also need a kinetic dynamo for this guy. So let's go ahead and make ourselves an iron mechanical component with the iron plates and a copper ingot. If you want to, you can make it in the engineer's workbench for half the price of iron. Let's go ahead and make one of these, and the copper coil block is LV wire coil, which comes from copper wire, which comes from the engineer's wire cutters on copper plates, which comes from copper ingots with the engineer's hammer. All right, we got ourselves a kinetic dynamo. And these water wheels, they are made out of water wheel segments, treated sticks, and treated wood. So we're going to need 4 of these for every one of the water wheels. All right, we got 4 water wheel segments for 3 water wheels. The thing that was holding us back was steel. So to make one of these water wheels, you do need a steel ingot in between, which we've been getting from our blast furnace. So let's go ahead and turn these 3 into 3 water wheels, like so. There we go. Now we have our kinetic dynamo and our 3 water wheels, and we are ready to put together our first water wheel from immersive engineering. All right, so this is totally up to you which direction you want to point it in. So let me go ahead and mine up these 2 pieces right here, or should I say 3. You're going to have to start off with a hole in the ground, okay? It is 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7. A 3 by 7 hole. Now we're going to use dividers for this. So whichever end you want to be the front, where the water is spilling, you're going to put 3 blocks here, 1, 2, 3. The opposite side, you're going to leave 3 blank, and you're going to put down 3 to block, like this. So you're going to have a 1 by 3 hole in the back, and then a 1, 2, 3, 4 by 3 hole in the front. And the lip is going to be twice deep. Now, the place that you're going to put the kinetic dynamo is either going to be on this side or this side. It just depends on which direction you want it to be pointing. I want both of the kinetic dynamos to be facing each other. So I'm going to put mine right here. So you have your 3 by 4 hole. On this side, the second space is where you're going to put it. You're going to go up 2, and then you're going to put down your kinetic dynamo right there. Wherever you put it down, the black hole right here, this is the front of the kinetic dynamo, so it will always face you when you put it down. This way, the backs of both of these units are facing each other right now. I have a surprise for you guys. On either side of this guy, we're going to skip one, put one down, skip one, put one down. It's in the same row as here. We're going to do this on the other side as well. Now that it's symmetrical, we're going to go up 5. 1, 2, 3, 4, 5. I like to use treated wood scaffolding because before you get your angel ring, you're able to climb the scaffolding to build. And I think that's cool. Plus, it is a really cool looking aesthetic for immersive engineering. I do enjoy it. And then just to break it up a little bit, we're going to put 1, 2, 3 regular treated wood planks in the middle, and then build up again on the other side, treated wood scaffolding. There we go. Then when we come in the inside, we take our water wheels, we go 1, 2, and 3. Very cool. Now this is the fun part. We're going to fill in the rest of the blocks. Some of them are not required, some of them are. But I like making it look like it's holding the water, even though some of these blocks are not required. So let's go ahead and fill in every block right here with the treated wood fence specifically. That's what I'm going to use. Like this. And then we're going to drop down one because the water is going to drop down. Boop, boop. Boop, boop. Okay. And then we're going to cross over here because we want the water to come down, hit this area, and then go backwards, making it spin faster. And I believe, yeah, on this side, I cleaned it up just a little bit. So we can get rid of this guy and replace this guy with more fence because I pulled it out to make it look better. So up from the top, like this, keep going, like this. All right, there we go. So we filled it in all of the spaces that we have left. Now, all we got to do is put in the water. And I'll show you guys how simple this is. We're going to need 6 buckets of water. 1, 2, 3, 4, 5, 6. All right, we're going to do 1 here. Boop. 2, 3. And then here, we're going to put it on top of the bricks. 1, 2, and 3. There we go. So these water blocks are pulling just a little bit. They're dumping into this hole. These 3 up here are doing most of the work. They're pulling this, pulling this. When they hit the rocks, they're spilling this way, and they're going to keep pulling it this way as well. Super simple. The easiest way to put the immersive engineering water wheel together. And I think it looks pretty cool. So now both of these units are making 81 RF a tick. So compared to this unit that we made last time, that makes over 200. This one is around 160. So you can see how it's better for the one block. It's more efficient, really, but it takes up a lot more room than the thermoelectric generators. The windmills take up a lot of room, and they also don't provide that much RF. So it's going to be a toss-up between using the immersive engineering water wheel or the immersive engineering thermoelectric generators. So the reason why I wanted both of these kinetic dynamos here with one block in between is because I wanted to show off another item. Last time we made the LV accumulator. So this accumulator is more or less a battery. It can have a throughput of only 256 RF a tick. So it is low voltage. When we go to MV, medium voltage, it goes all the way up to 1024 RF a tick, which to me is more within the respectable range, really, of energy transfer. So let's go ahead and jump towards the MV accumulator. We can make this guy. It's just as cheap as the LV accumulator. We just need to make a nickel plate, an iron plate, and steel ingots for this one. So let's go ahead and make another redstone acid bucket, water bucket with redstone. We can hammer down one of our nickel plates with our engineer's hammer. And that should be all that we need for the MV accumulator. So if we put this guy down, all of the sides are going to be blank, as you can see. What's great about the accumulators, which they used to be called capacitors, you can use the hammer to right-click all of the sides. So now all of the sides are input except for the bottom. Let's go ahead and fix that. We'll put this one up high like this, and we'll hammer the bottom as well. And as you can see, mining it up and putting it back down, it remembers. So it's not like the metal barrel. It's not like the fluid pump. This one, when you mine it up, it remembers where you hammered the input and the output. So I like to put these guys down, hammer everything to input so that I don't make any mistakes, because we want energy to input into this guy. Both of the kinetic dynamos are facing each other. We don't need to right click input output on these guys. They will always output, right? So what I'm going to do is I'm going to put the MV accumulator right in between, since both sides are now set to input. Water wheels are really tricky, because if you mine this up, the kinetic dynamo, and then put this guy down, configure it out, and put the kinetic dynamo back, it will keep spinning, but the kinetic dynamo will not be gathering any RF, because it needs to be put down in that exact order. Kinetic dynamo, and then the water wheels need to be attached. So if you put down the dynamo, attach the 3 water wheels, remove the dynamo, the water wheels won't break. They'll stay there. And then if you put the kinetic dynamo back, it will start spinning, but it won't register it as having any water wheels. So be sure, put down the kinetic dynamo first, then attach the water wheel. Now that this guy is set, we can change the top or the side to output, and this is where we can move power from the MV accumulator now out and move it around our base. Now what's great is we can also show off how to make the MV wire relay, the MV wire connector, the MV wire coil, as well as insulating it so that it doesn't zap us with the tough fabric. These guys are now being upgraded to electrum. So we have electrum ingots with terracotta, and a little bit less with terracotta for the wire relays. The wires are going to be electrum wires, which are the wire cutters with the plates. The plates are the electrum ingots with the engineer's hammers. And the electrum ingot, of course, is our alloy kiln over here with silver and with gold. This one has the constantan still in it, which is nickel and copper. All right, so before we make the MV stuff, let's go ahead and check this guy out again, because I'm having a blast with this current transformer. This is new for me, so I really appreciate this. I've always just trusted what the wiki says. So let's go ahead and grab LV connectors and LV wire, because this guy, both of them together are not going to make that much power. So let's go ahead and connect, and then we can connect to the trash can like so. And how much are we making? 252 flux per tick. Oh, but I gotta watch out, because this is not how much power the water wheels are making. This is how much power the MV accumulator is letting out. So it's gathered some power inside of it already. So to drain the MV accumulator faster, we definitely should grab some of our MV wire relays. Let's go ahead and make these guys. We got wire connectors. We'll grab these guys, and we'll make some wire coil, which we don't have any of the electrum wire. Let's go ahead and make that. And we need to get our wire cutters going. And let's see, let's just go ahead and make a stack of these guys. And we'll make 8 of these cables as well. There we go. And let's go ahead and replace our LV, MV trash can and MV on the MV accumulator. Wire coil, we're going to be careful not to zap ourselves. And let's see now. 1015 flux per tick because there is more RF inside the battery than the water wheels are making right now. 256, of course, was max for LV, and max for MV is 1024. So we just need to let this guy drain real quick. While it's draining, let's go ahead and insulate our MV wire coils, because these guys, they are not insulated, so they will zap us if we touch them. And to insulate them, all we need to do is put 4 of them in the crafting grid with tough fabric, and it turns them into the insulated version. So let's go ahead and do that. There's 4 insulated, and then we need to snip the other 2. So let's grab our wire cutter. We can go snip, snip, and craft these 2 insulated, and then reattach it, of course, because we want this guy to drain. Boop. And boop. And now we don't need to worry, it won't zap us anymore. The insulation we're not going to be able to do with HV, with high voltage, only low voltage and medium voltage. And there we go, the battery is finally empty now. It emptied completely into the trash can. And now the throughput, the 2 kinetic dynamos into the battery is empty. It's going through the wire at 159 flux per tick. So be sure that when you're testing your setups, that you have to take into consideration that the battery has to empty as well if you have a battery buffer. We did the same thing over here. All of these thermoelectric generators are going into the battery, and then we tested the battery, which the battery has a throughput as well of, what is it, 256? So this is pretty cool. So for sure, 2 kinetic dynamos set in between, going through an MV accumulator, it makes, when it's completely out of buffer, 159 RF a tick. So let's go ahead and test this out again. Let's make sure I didn't make a mistake in a previous episode. Let's test this guy out as well and make sure that we had the correct number. 255 flux per tick, and it's not limited by the cable, it's limited by the LV accumulator. So since we're upgrading more or less to MV already, let's go ahead and we can make ourselves another MV, and then we can switch out the LV, make sure that everything is running on MV from now on. And this will probably be the last time that we make the treated wood this way with the buckets, because now that we have power, we can set up machines to be able to create the treated wood for us. And MV accumulator, and we're going to do the same thing. We're going to put this guy down, and we're going to make sure that we hammer all of the sides to input first. And input. There we go. We don't need to worry about the bottom, because we're going to be putting it down on top of the treated wood scaffolding, which doesn't have any room there either. All right, MV, we'll use LV and LV cable to connect like this. That one thought I was clicking across. And LV and LV. Looks like I'm missing a cable. There we go. Okay. So LV, since these guys are not transferring that much power anyways, and inserting, it's not that much power anyways. The MV accumulator now, we can output here, and now we can use the MV cables here, and we have MV over here. We have MV wire and insulated MV coil right here. All right. So now, yep, it's doing 1021 RF, but because the MV accumulator already has power inside of it. When it empties out, we'll see if we have the same number as last episode. All right, there we go. It has drained itself completely now. And now we see that from these 12 thermoelectric generators running through the MV accumulator, 12 of these generators makes 341 RF a tick, which is actually pretty good for with how low a footprint that this makes. Like, it doesn't take up that much space. I would say the water wheel takes up more space than the thermoelectric generator. And this is pretty awesome. We're making 341 flux. This can still be expanded too, by the way. I can still add another 4 and only need to add 1 block of water on both sides here. And another 2 on the other side. And then I just need to add lava. Two buckets of lava, 2 buckets of water, and 4 more of the thermoelectric generators. And LV, we're going to go wire to relay, and the same thing on the other side. LV, wire to relay. There we go. We added 4 more to this setup that we have going right here, and we are now up to 453 RF a tick. 453 for just this small area. So the thermoelectric generator is the clear winner between the windmills and the water wheel. But looks-wise, I would say I still think the water wheels are in first place by far. Same thing though, aesthetics, you know, we could put the water wheels down in the ground. We could put the thermoelectric generator down in the ground and build a singular cable that comes up out of the ground for this. We can hide them and it looks just as awesome. So this is more of an aesthetic look. It's decent power, but now that I've learned how the thermoelectric generators work, this is much more power for the space it takes up. But you guys tell me, what do you guys like more? The immersive engineering water wheel or the immersive engineering thermoelectric generators? They do look really cool. Like I might build more of them just because I want to see them in action.
Thank you so much for joining me today. Smash like to show your appreciation and consider leaving a boom in the comment section below. Also, click on my dude here to subscribe for more Let's Plays. Ooh.